Good evening, friends. Welcome to Eastern Academy. We are into embedded system programming, and today's session we're going to discuss about microcontrollers. That's a very critical part in your embedded system programming. All embedded systems are almost using a microcontrollers. Understand? So today we will discuss about what is microcontroller. So before we get into the microcontroller, we will just review what we discussed in the last four sessions on microprocessors. That's very important. Generally, you'll understand about microcontrollers. And this will be a session 1. And I think most of you are now discussing with me on WhatsApp. So I'm quite happy. And start solving a problem in C problems. That's fine. So, and this session is going to be input and output. I'll explain this very clear. And this is fairly a critical session today. Don't go too in-depth. Don't go too technical. We will discuss all these things in our digital electronic session. Now, don't go too in-depth to confuse yourself. That's why I can tell you. And at the same time, you can ask me any doubts. Okay. So let us get into the board and start discussing about our microcontroller. And the beauty of the thing is, what we discussed was initially, IC called microprocessor. It's nothing but CPU on chip. So if you have any doubt, what is CPU? What is microprocessor? Both are same. Both are same. But nowadays, initial days, CPU was made with so many ICs. So many components were used to make a CPU. Intel put it on single IC. That's why it's called CPU on chip. Yeah, IC is nothing but we have so many components we use, that is switches, am I right? Or a resistor. We predominantly use two components. In this component, switches, there are two types of switch. One is called manual, one is called automatic. The difference between manual and automatic is the manual switch, you control the switch by hand. In this automatic switch, you control the switch by voltage. That is, voltage is controlling a voltage. And that switch is nothing but transistor. How do you build a transistor? Using silicon, metal. So what people did was use the silicon and build the transistor. Transistor is a component which is used to two purposes. One purpose is a variable resistor. Other purpose is switch. When you use it as a variable resistor, we call it amplifier. This is called analog electronics. When you use a switch, we call gate. That's called digital electronics. Using these switches, using this transistor, we connect them and make a lot of functions. This is called circuit. This is called circuit. What people used to do is they take a board with the holes and they put the transistors inside the holes and they connect to the wires. This is what? This is on paper. This is on board, physical. So you are converting. You cannot use it on paper. You can draw anything on paper. You cannot use them. You can use it only on the board. On the board, when you do it on physical, if you have few transistors, fine. That time there is a person from Texas Instruments called Jack Kilby. He invented a new method. Within silicon, they put the circuit. Within silicon. Previously, within silicon, they built only one transistor. Now they put the entire circuit. So this, and then what, you cannot use it. What they have done was, they put a bottom base and they put the silicon. They connect the wires. They give you the pins. This is called what you, since you put the circuit inside the silicon, this is called integrated circuit, IC. That is what the meaning of, somebody has asked about what is IC. That's why I'm explaining. IC is nothing but we put the entire circuit on a silicon. That's it. Then I make them to use it. Now the same way what happened, initial days they built the computers using a CPU. Inside the CPU, they had lots of circuits, big circuits. All the circuits were used separately on the boards using transistors. But later, they put everything, the entire circuit, CPU circuit, inside the silicon and make it as a single IC. So it is nothing but, integrated IC is nothing but you put the circuit on silicon. That's it. There's nothing big explanation. Instead of doing it outside with wires, you do it inside the silicon. That's a field called IC design. That's called VLSI. And what we are discussing is called software design in electronics. Called the embedded. Okay, the third one is called board design, called hardware. Actually, you have three fields in electronics now. Okay, all the three are now have a huge requirement of people, and all the three are very interesting. Each one is having their own advantage. Okay, now we discussed about this microprocessor, which has pins. And instead of drawing one pin like this, we made a thing like a single pin, single wire, and put a slash, pins 10. That means address. And there is a signal called write. There's a signal called read. There's a signal called data. We will discuss in depth about ICs and everything in our electrical and electronic sessions. Okay. And what is inside the microprocessor, how they are working, the memories are working, we will discuss on digital electronics. Okay. But try to understand at the top level what the functionality does. They have a pin, ICs have a pin, and the pin are having so many functions. Now, if you write a program, CHAR X, X is equal to 10. Now what you are doing is, you are writing 10 into X. What is X? In your memory, I write a program here. X is equal to 10. That means that in your memory, you have some location called X. And there you write the value 10. but you are replacing with X. So this is actually X. This is called AND X. AND means location. Location of variable X is called AND X, or we simply call this as a address. Or in C, we call this as a pointer. All are same. Pointer, address, location, all are same. Don't worry if you don't understand this. This is a very top level class. Okay. When you go in depth, that's why I made a session as a 2 months or 4 months or 8 months or 12 months. You can be with that till you understand. Okay. Maybe if you watch this session after your electrical electronic, digital electronic session, you may understand better. Okay. But fortunately, if you think that you can understand at the block level, then this will be very good. Okay. Now, what I'm trying to say is that how the software is controlling this. That's a trick. Now, if you say CHAR-X in the C program and you say X, that means that this compiler will create a symbol table and it put for symbol and address. For the symbol X and X, you put 2000. So what is happening is when you say X is equal to 10, you are trying to write what is the meaning of it. You are writing 10 into location 2000. That is at location 2000. You are trying to write 10. You may be thinking that it's too complex, but this is the only thing you have to know. This is as simple as that. The whole embedded system program lies on only this. Without confusing, if you understand, it's great. So that's why I'm trying to connect with you C and the microprocessor and memory. Now, when you put 2000, the address will come here. 2000 will come here. Let us assume that we have 16 OS address line. 2 power 16 is 65,536. Now it's 2000. It's pointing. Since you are writing, write becomes 1, read becomes 0. And you are writing 10. 10 comes here. So now what happened? This goes to memory. This goes to memory. This goes to memory. This goes to memory. But here is only one problem. The major problem is when you put here CHAR-S, when you put here CHAR-X, is a problem. The address given by the compiler, the moment you write a program and compile it, you give it to compiler, or that's translator. The translator will convert that into machine language. That time, he will give an address for the X. This address is decided by the compiler. You cannot specify. Let us say you want to write that 5000. If you write the program like this, it's not possible. You cannot write whatever you want. That is not possible with this, because this address, when you write a program, see, this is also same. I can give int also, but int means 32-bit. That's why I'm always use CHAR. Both are same. Now, when I say CHAR-X, X is equal to 10, the compiler allocates for this a location on the memory, and X 2000. But this is decided by who? Compiler. Suppose I want to store at 5000, then Dennis Ritchie, our great man, who invented the C program, the C language, he has given a method. He said that, hey, do one thing, man. You don't put char X, put star X. X is equal to 5000. You put star X is equal to 10. See that now? One extra statement. Now, if you do this, if you put star X is 10, X become 5000 now. You can write wherever you want. Write is 1, read is 10. You can write. Do you understand now? Do you understand now? What is the difference between CHRX is X is equal to 10? There are two programs I've written. Try to understand. If anybody don't understand, let me know now. These two are very important for us as a electronic students, as a embedded system programming, as a computer architecture. You want to understand these two statements are very important. If you don't understand these two, let me know. If you don't understand, let me know where you don't understand. Yes, you normally, this is, you cannot. That's a problem. The AND X is, if you write a program now, char AND X and the AND X, that's not, if you say char X, AND X is equal to 2000, 5000, the compiler will give you error. It does not. The moment you put X, then you lose the control. See, please understand. Please understand this. This has to be understood every embedded system programming people or every C programmer. When you declare a variable, you may say X or A or B or anything. You may say that A. You may say anything. It doesn't matter. If you give any name, that means that this is stored in a memory, a space allocated. So for A, there's a space in memory. This is called variable. All variables are stored in memory. Understand that. Correct. Yeah, we will discuss about that. When I say CHR A is a variable. So every variable, there is a space in memory. If you say A, B, C, that means that A, B, C. But this we call address of A, address of B, address of C. This is A, B, and C. When you say A equal to 5, you are replacing the A with 5. You say B is equal to 6, you are replacing B with 6. C is equal to 5 is 10. So understand the difference between A and AND A. A is a content. A is a content or variable or data. Understand this. Whereas AND A, AND B, AND C are called location or pointer or address. All are same. In hardware, we call address. In software, we call pointer. In English, we call location. Same way, content in English, variable in software, data in hardware. All are same. Please understand that. Yeah, I'll tell you about that. Now I'll tell you. Now what happened? When you declare this ABC, who will declare the location? That is a problem. When you say ABC, and if you give it to compiler, then the compiler will create a table called symbol table. And the compiler will say AND A, some 1000, AND B, 1002, AND C, 1003. Whatever it is, he may do his own wish. He may allocate this as a 1000, 4000, or 5000. You cannot ask. The allocation of address is not in user hand or programmer hand. Programmer, please understand, programmer cannot fix the address. Please understand. It's very, very important for us. If you don't understand, ask me once again. That means that when you declare a variable, a location is allocated in memory. The address of the location is allocated by the compiler, which you do not have the control. You cannot say that I want to write on that location. That is not possible, please. Do you agree that? So every variable you declare in a C program, that is corresponding memory is allocated. Depends on size. CHAR means 1 byte, short means 2 bytes, long means 4 bytes, and long means 8 bytes. Is it clear? Don't allow me to proceed if you don't understand this. This is a base. That's why I spend time. I told you I'm not worried about schedule. I may even take one more extra day and teach you. On Saturday or Sunday, if you want, I can take a class. Don't mind. But that's not a very tricky thing. But you have to understand. I finished the schedule, and if you don't understand, means operation successful, patient dead. That's not right. We have to make an operation such a way that you want to be live. If I teach and you don't understand, that's waste. Let us not go by that method. So please, if I declare, understand one thing. Now I say only one thing, you understand. Now, if I write a program int A, that means that the A is having a location in a memory. That location is called and A. That is called pointer. But where it is, you don't know. That is given by the compiler on a symbol table. Symbol pointer. And A 2000. But you want to see where it is, you can do. You can say now printf %d, comma, and A. You can read. You can find the address, but you cannot say that and A is equal to 5000. That is not possible. Now let us see that. I understand. Now let us try to run a small code and see that. Understand? So we don't accept just like that. I'm saying something. So it's very important that trick I'm trying to explain to you, that try to understand every small points. But at the same time, you should not go in so depth. I know that these are all very important for every embedded engineer. One minute. Let me open the program and okay, let me share it. Let me share the screen. Now, let me write a program. I say now, CHAR X. I say printf X is equal to 10. I write printf %d, %d. I print both address of X and the X content. You understand now? I print both. I print X and X, both. Now, let me save it. Compile. I run it. See here, this is the address allocated by the system. 64,22,047. And 10 is a variable stored. Now let us see that. I don't want this address. I want to store it at 5000. Now I say and X equal to 5000. I'm trying to say and X. Now let us compile it. See, there is an error. Left operand is wrong. I cannot do this. This is a wrong line. See, he has shown you the red signal here. This is a compiler error. The compiler itself will not allow you to change the address allocated by the compiler. Please understand. Because he said that you don't have a permission to give an address for this. I will do that. Then only our man did. Who? Dennis Ritchie. Okay. He has given a provision for you. What provision? That's a beauty. That's a beauty. That if you understand, I'm quite happy. That means that you have a memory. Let us assume that you have a memory starting from 0 to 65,535. That is, your microprocessor is having 16 address lines. 2 power 16 is this. You write a program, char star x. X is equal to 9,523. Star x is equal to 25. Now, at 90523, 25 will be written. Understand now? Now, this is x. This is star x. You are not changing the and x. You are changing x. Yeah, that we will discuss. Percentage U or percentage P. Both of percentage U or percentage P or percentage X. That let us not worry. Let's not worry now. Which one you use it on the printf. That is only printing. Okay, U means unsigned and X is hexadecimal and P is a pointer. That's the only thing. So you understand now. That is so very important now for us. That means that I make your Dennis Ritchie has given you the option to control the microprocessor pins. If you write a program, char star x, x is equal to 5,000. Star x is equal to 25. Then on the address line, you are putting 5,000. And on the data line, you put 25. On the control line, there are 2 control lines, read and write. Since you are writing into the memory, because you are storing 25. Write becomes 1, read becomes 0. Now, if I do like this, star y, then you put x is equal to 4,000. Star x is equal to, y is equal to star x. Now right hand side, RHS, there's always read. That means that I'm going to read from 4,000. At 4,000, let us assume that you have some value of 33. Now this program will read from 4,000, 33, and y. The compiler could have allocated for y some address called 1253. So at location 1253, you are writing 33. That means that you can read from anywhere. So you have 2 options. One is you can read from any memory location. You can write to any memory location. That's a major advantage of your microprocessor. And see, how do you do that? Quite simple. char star x. X is equal to address, whatever address you want. And star x is equal to whatever data you want. That means that these 2. So now, since our microprocessor has about 16 address lines. Now let us take a very simple case. Only 6 address lines. To understand, that is easy. 6 means your combination is from 0, 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1, 1. That is 0 to 63. That's it. You have only 64 location. Now, it means that you have 64 units are there outside. 64 units. Please understand. Which data? This data is stored in which memory? Data is stored in. Wait. You don't get confused. You don't get confused now. That's what I'm coming now. There are 4 types of blocks. There are basically 2 blocks. One block is we discussed last class. The one block is called output block. One block is called input block. Each one is only one block, 1 byte, 8-bit, 8-bit. All are connected with your microprocessor. All are connected. They are called D0. I'll explain to you now. Data is stored in where? That I'll explain to you now. Now, this 8 bits go out. This 8 bits comes in. This is a type 1. This is type 2. Understood? Apart from that, we have discussed about 2 more. One is called ROM. One is called RAM. So the last class we discussed about memory map. The memory map we discussed about ROM, some size, maybe about 16 bytes. ROM has about how many bytes? 16 bytes. Then I may be having one more block called RAM. This is read only. This is read write. My program, which I write here, CHAR star X. X is equal to 31. This guy is 16. So 0 to 15. 16 to 31. But I have only one output block. And I have only one input block. That means that here's a switch. These are controlled by you. Normally, they are not connected. How do you control? Because I explained to you that there is a logic outside called select logic. If you give a number here, let us say this guy name is 32. This guy name is 33. Like your name, let us say you call me Balaji. My name is Balaji. I compare both. Then I'll say yes. Okay. But if you call me Ganesh, I'll say no. It's not my name. Understand? Now Ganesh will say yes. Like that now, this guy's name is 32. This guy's name is 33. This guy is having 0 to 31. Sorry, 15. 16 to 31. I've explained about how the notebooks we allocate pages. I explained in the last session of memory map. Now I write a program. If I say character star X, X is equal to 31. Star X is equal to 55. Now 55 will come here, data. Address will be how much? 31. And write will become 1. Read becomes 0. Because I'm writing. Since this is 31, 31 is on RAM. It will be written on the RAM. What data? 55. Understand? Somebody asked where it will be written. Now it is written on the RAM. RAM is nothing but read. RAM means read, write, memory. That means that there's no output. Please see the difference here. This is called input. From outside, it's coming inside. This is called output, which is going out. These are called memories. Memories don't have any output or input. You can write and read. You can store something, you can read something. That's the only thing. Yeah, well, no, I didn't mute it. You can ask anybody, anytime.
Sir.
Yeah,
Good
yeah.
evening, sir.
Yeah, good evening.
Sir, just a small doubt, sir. Here, character star X you have declared, right, sir,
Correct, yeah.
in the program.
Yes.
So, can if we declare character only character X, then X will be data, right?
Correct. X will be
Firstly,
data.
one.
Correct.
Okay, okay, sir. Got it. Got it.
When you put star X, X is become address.
Yes, yes.
When you
Got it.
put when you
That is
put
my.
X, when you put X, X is data. When you put star X,
Yeah.
X become address. And star X become data.
Okay, sir.
Now X is address, star X is data. Very good doubt. That's correct. Yeah. That will be useful
Okay.
for somebody also. Thank you. Very nice. Okay, now. So now when I write a program, I give it to compiler. Compiler will give the machine code, some 75, 46, 37. This is called binary file. I load this into the ROM. I load this into the ROM, my file. Understand? So when I compile the program, I store it in the ROM. That is read-only memory. That means that microprocessor will power on. When you give a power 5 volt, he will read from the ROM and he will start executing. While executing, you put it on 31. He will put 31 and your data is 55. He will write here. Suppose if you say 32 here, 32 does not belong to the RAM. 32 does not belong to the RAM. 32 belong to the output. So there is a 8 pins. Please understand one thing. There is nothing called 1-bit microprocessor. No. All the microprocessors, the minimum is 8. 8, 16, 32, 64. There is nothing called 1-bit microprocessor. Microprocessor cannot write only 1 bit. Let me be very clear. The microprocessor can minimum write is how many bits? 8 bits. That's why minimum is CHAR. Dennis Ritchie did not define anything less than CHAR. For example, you have CHAR, short, long, and long. This is 8-bit, 16-bit, 32-bit, 64-bit. There is nothing called 1-bit or 4-bit. So always you can write one for 8 bits. Suppose here there are 8 pins. There are 8 pins. Understand? Now, if you write a program here, you write a small program now. Let us write a small program. Same program. I don't change the program at all. Character star X. This will work for 8051, ARM microcontroller, or PC, everywhere the same concept. If you understand this, you understand microcontroller. Please understand. X is equal to, 32. I've given 32 now. And star X is equal to 1. 1 means binary. That is 000001. Understand? Now, since the 32, the microprocessor gives 32. And you are writing. So write become 1, read becomes 0. Now this 32 is 32 matching. So now this is selected. So this switch is on. So this data goes on. What is the data? 001. So 0000001. But the beauty is, for us only 0. On a wire, 0 means 0 volt. 1 means 5 volt. If you connect here a bulb, LED, or a bulb, that guy will glow. So this is called output program. Using this 3 line, you can blink. Let us assume that I have a LED here. I want to blink this. I want to on this LED. Let's say this is red. This is green. I want to on the green LED. What will I do here? I write 128. Sorry, 32 is same. Data is 128 because last LED 10000000. Am I right? This is address I don't change. But if you give here 35 or anything, it does not work because this address is 32. Now you understand about one block is called microprocessor. One block is called output. One block is called input. One block is called ROM. One block is called RAM. That's all. This is what. Now, if I say that, understand one more thing. I say here X comma Y. I'll explain very deep now. I give you the top level, I'll go in depth. Okay. Now I say here Y is equal to star X. Now X is 33. Now you see here X is 33. So this is matching. This address. It's coming here. It will come here. This 33 is matching. Now I'm reading. I put right as 0, read become 1. Because this star X is coming right side. RHS. So now you understand the importance of C. If you know C, you understand everything. The whole micro embedded system is as easy as C programming. That's why I'm trying to explain to you that what is this. Okay. Don't take very serious. This is what all about. What I am discussing is an embedded system. If you think something else I'm going to discuss, you think great. But this is what all about. I have done it 35 years, only this. Nothing more than that. If you assume there is something is great in embedded system, I'm going to learn something great, then I cannot help it. What I am discussing now is a part of embedded system. That's all. It's as simple as this. I'll explain to you now more and more. I know that. But if you know this, if you know the two things, one is, if you know two things, one is called, I put star X is equal to 32, star X is equal to 1. That means that this is on LHS. I am writing. That is called output. Now, if I do same thing here, Y is equal to star X. This is coming on right side. This is called read or input. You are getting, for example, here, forget about this. Here, I connect a switch. 8 switches, 0 to 7. 8 switches. Everything looks to be very confusing for you because of only one reason. You know what is the reason? All in binary. The moment you start fluence with when you go to the new place, when you go to any place, let's say that if a person from North India comes to Tamil Nadu, or if I go to Delhi, if I go to Bombay from Chennai, if you go to Germany, when I was in Germany first 2-3 days, I could not do anything because everybody speaks on Germany. Everything was written in German. That's it. So the moment you understand, then you become so enthusiastic and you settle there itself. Same way. When you go to the Bombay, first few days you'll struggle, then you'll settle there. The same thing here. This is the language of binary, some small things. Otherwise, it's a very common what you do today. Now, when the switch is off, I get all zeros. So when I do Y is equal to star X, I get 0 here. The moment you on the one switch, that become 1. So if you write a program 33 and Y is equal to star X, I will get 0, 1. Now let me write here more clearly. Now I don't want to write the code in ROM, RAM, everything. That's the thing. Now I have a microprocessor. That's always, don't go inside, outside only. We are worrying about only outside. Inside is all about your C programming. The inside is only about C programming, nothing more than that. We worried about only outside. Now, here I have two components. One is called output. One is called input. This guy is having a select. This guy is having a select. Now this guy is having 8 pins. D0 to D7. It has 8 outputs. And same way, 8 inputs. D0 to D7. I0 to I7. Okay. Now I have two logics here. This guy name is 32. This guy name is 33. That means that 32 means 1000. This is called 32. 33 means 10001. Everything is binary. I'm writing that just for you. Now these address pins are connected here. Understand? Now if I write a program, CHAR star X and Y. And if I put X is equal to 32, star X is equal to 1. Let us assume that I connect here a LED, blue LED. I connect a blue LED. Now I connect the green LED here. Bit 0, bit 4. On bit 7, I connected red LED. Right, I connected. Bulb, understand the bulb. Now I have a switch here. Eight switches. All the switches are connected to 5 volt. Understand now? All the switches are connected to 5 volt. Now, if I wanted to on the red blue LED, this is simple. I have 8 bits. 7 is a MSB, 0 is the LSB. Now I want red LED, it's a blue LED, that is a LSB bit. So 1, all the other bits 0. And I want output. The output address is 32. I say here, C program, X is 32, star X is 1. Now this guy will give 32. Write as 1. Read as 0. Then data will be 1. That is 00, 001. That goes to here, 0000. But only this is selected. This is not selected. So this is off because this guy name is 33. This guy name is 32. This is called output. Now I wanted to on the green LED. That is 4. The fourth bit become 1. This becomes 0. That means that the value is 16. I put 16 here. That is going to be on green. I want to on the red LED. The last one is 1. All are zeros. That means that 100. It is on. I can make that. Same way, somebody has doubt. So yes, we are assuming right now everything is 5 volt. You are right. We are assuming everything 5 volt. We will discuss about voltage later on the electrical and electronics topic. Right now, we assume everything is a 5 volt device. Okay. All the inputs given to the microprocessor is 5 volt. Yeah, now same thing. Now somebody has asked the question, how LED is blinking? Understand? I do not have to touch anything here. I'm writing a small C program here. You see here, I write, let us say, I want to make the blue LED blink. I want to write the blue LED blink. I say long I. I have character star X. Now X is equal to this one, 32 address. If I say star X, I have to say X. Now, if I say, see here, while 1. While 1 means always true. Or I can write on another easy way. I can write another way. Say, I'll say loop. I'll say loop. I'll say now here, star X equal to 0x 0, sorry, 1. 1. 1 means 0, 0, 0, 0, 1. So what happened? Now red is, now in this case, blue LED on. I'll say here next line, I do here is very simple. For I is equal to 0, I less than 10,000, I plus plus. What I'm doing now? Can you tell me now? If I write a program like this, for I is equal to 0, I less than 10,000, I plus plus. What I'm semicolon here? What can anybody tell me what is exactly the meaning of this line? Nothing. What I'm doing is telling the C program, you start with 0. Up to 10,000 count one by one. That means that you are sitting in a room and on the light, then you say, you close your eyes. 1, 2, 3, 4, 5, 6, you're counting. Like that, this guy is counting. This is indirectly called delay. Now what I do here is, I'll say now star X is equal to 0. That means I off the LED. 0 means off LED. Now we'll say for I is equal to 0, I less than 10,000, I plus plus. I once again give a delay. Now I say go to loop. I go here. I do once again. Now it's blinking. Am I right? This is what I'm doing, blinking, nothing. I don't touch anything in the hardware. I touch everything in the software. That's why I always say that please master C programming. This is only very simple one. When you start doing anything big, nothing has to be done in hardware. Everything on your hand is in software. That's why I started with C programming, I told you. Now the third one is this. Let us say that when I press the first switch, I want the blue should be on. When I put the second switch, I want the green should be on. When I put the third switch, I want the blue should be on. Now what I'm doing now? Simple. See here. CHAR star X, comma Y. Understand? I say X is equal to, say I say star out and comma star in, comma Y. Now out is equal to 32. 32. In is 33. Now what I am doing now, loop. Once again loop. Start with always loop. Because you people have yet to learn the programming. Now I say Y is equal to star in. I'm reading now. Am I right? Now I'm reading. If it's not pressed anything, if I say if Y equal to 1, if Y is equal to 1, I'm checking. I say star out is equal to 0x, sorry, 1. That's a 1. If I say if Y equal to 2, then this one is pressed. These two are not pressed, only this is pressed. I say star out is equal to this one. That is 1, 2, 4, 8, 16. If Y is equal to 4, 4 means 1, 2, 4. Not like 1, 2, 3 here. Here all binary. 1, 2, 4, 8 like that. 4. Star out is equal to last one, red, 128. Go to loop. If you don't understand the program, let me know. Go line by line. The only small program. If you don't understand the program, let me know. This is what we're going to practice in our next session called embedded system programming. Understand? Now you try to understand what is this. In our embedded system programming, we are going to practice this. That's it. How exactly we are doing this. Then I'll give you the exercise, and like how you do see exercise now. That time you will do the exercise on embedded system programming. Understand? Now, let me, I just tell you that how the input output works. So what happened now is this. You see here, I have an IC called microprocessor. I have one called ROM. I have one called RAM, where I store my variables. Then I have output. I have input. Now what people did was, these are all separate ICs one time when we were studying in college. Suddenly what happened? They put all of them in a single IC. Everything on a single IC, single silicon. All these things. They put everything inside the thing. It's a magic. They put everything in the silicon. And these pins only will come out. These pins only will come out. This is called output. This is called input. You understand? This is called output, this is called input. And this IC is called micro. There's no difference between this normal circuit. What we did was, somebody asked the starting of the case, what is IC? IC is nothing. I draw a circuit. Previously, I'll start doing soldering. Now, I put the circuit inside the silicon. That is called IC. Then, what they did was, they put multiple ICs, all the important thing, and put it in a single silicon. They call microcontroller. That's the input, output. These are all not visible outside. All the connections are internal. All the logic, select logic, chip select logic, or internal. You don't know everything. They will tell you, if you buy a chip from STM, ST Micro, they will tell you the address. If you buy from Atmel, they will tell you. If you buy a 8051, they will tell you. Everybody will tell you the address on the data sheets, which we are going to see it on the embedded system programming in depth. Now, don't worry. Now, try to understand. I had the same thing, microcontroller, ROM, RAM, output, input. I put everything inside the silicon. This is called microcontroller. Nowadays, the bigger one is called SoC. Both are same. If you use it on the embedded jobs, I call microcontroller. If you generally use it on the bigger application, like a smartphone or laptops, we call SoC. System on chip. And microcontroller, both are same. There's no difference. Don't get confused between all these things. The problem is, whatever could be the thing, how they package it. At the end of it, your software is executed by your microprocessor. Please understand. Your software is executed by microprocessor, and your program is going to be in ROM, and all the variables are in your RAM. And you talk to the outside world through output and input. And you can have any number of pins, not only 8. If you want 16 pins, I can add one more output. If you want 24 pins, I can add one more. And how many pins you want, you can add that many output blocks here. But this will be 32. This will be 33. One more block means 34. One more block means 35. No block should have a same address. That's the only logic. So the trick here is this, where this is actually, you can compare the microcontroller with your brain. With your brain. Your microcontroller can be compared with the brain. That is, your brain has a process unit, a memory. This is called frontal lobe. This is called temporal lobe. Like that, there are so many blocks which controls your hand, which control your eyes, which control your mouth. Like that here. This microcontroller is the same thing, where you can control with a microcontroller. All are inside. You get only inputs. You get only outputs. You can connect to a keyboard or keypad. Connect to a LEDs, motor, 7-segment, LCD, display, everything is the control. How we are going to that side. See, this is what the basic. Now, how are we going to control all these things? That is what we are going to discuss about in our embedded system programming very thoroughly. Okay, that's a session. After the embedded system, we are going to use that. So please understand that. So if you have any doubt on this, you can ask me. That is, microcontroller is nothing but a single IC, which includes microprocessor, ROM, RAM, output, input. You don't see other connections, everything inside. They're all inside. They are not shown to outside. You will see only a chip with pins. All are inside the silicon. They put a cover on top of it. You don't see that. And you have to give only a voltage here, 5 volt. That's it. So, with the help of 2 softwares, only 2. One is star X. X is equal to 32, some address. Star X is equal to 55. This is for output. Here, star X comma Y. X is equal to 3000. Y is equal to star X. This is for assuming that this key address is 2000. This key address is 3000. That's it. Now we related the C with the microcontroller and the input or output. If you think that there's something great, big is just be there, then maybe after you have to work for 20-30 years, then you will realize that there's nothing. You better understand that there's nothing. If you say that there's something is there and Balaji is not telling, then it's your wish. I worked 35 years on this field. I'm telling you there's nothing. If you know this, you are wonders. You can do wonders. Yeah, they're all coming into programming. You can do programming anywhere. You can do oops. Who stops you? You can run a program in Python, Java, everywhere. But somebody have to use it now. If you say that I know Python and embedded, if you say that I know C and embedded, you will get an offer from 100 companies. If you say I know Java and embedded, you will get an offer from 1 or 2 companies. If you say I know Python and embedded, I know oops and embedded, okay, but if you say I know C and embedded, you get big offer. But after C, I know C, I'm very good at C and embedded. I know oops also. Then value. If you don't know C, you know only oops and embedded, then nobody bothers you. Nobody wants you on embedded. Please understand that. Be very, very clear. Oops are all software. Nothing to do with this. This is basics. What I'm discussing is a very bottom level. So let's take a break for about 5 minutes. Some more question. One more question. Okay, thanks. So let's take a break for 5 minutes. We'll come back. I'll just give another very critical parts about embedded microcontrollers. Okay, This is another very important one. Thank you.